Hello, everyone, and welcome to today's exciting webinar. I'm Tim Stark and the host of today's exciting event. I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign, and also the technical director of the Fabricated Geomembrane Institute. This is our fourth webinar of 2020, and the remaining 8 webinars for 2020 have already been scheduled with great speakers and timely topics, which I'll show on the last slide today. During today's webinar, we welcome questions and comments which can be typed into the questions box in the control panel. You may send in your questions at any time during the presentation, and our speaker will address them at the end of today's presentation. The recording of this webinar and a PDF of the slides will be made available on the FGI website after today's presentation. PDH certificates will be sent automatically to all who attend the entire webinar today. Okay, today's webinar speaker is Dr. Richelle Delia. Dr. Delia is a product researcher for Owens Corning Geosynthetics in Granville, Ohio. Richelle received her PhD in chemical engineering from the University of Texas at Austin, and has been with Owens Corning for 7 years and has been working in the building materials industry, focusing in on geosynthetics. Richelle is also an active participant in the FGI's Women in Geosynthetics program. The title of Richelle's webinar is Environmental Containment Using Factory and Field Fabricated Geomembranes, which is an extension of a presentation that Richelle gave during Geosynthetics 2020 in Charleston, South Carolina. Richelle, thanks so much for squeezing this webinar into your busy schedule and joining us from Columbus, Ohio.
Certainly.
The webinar controls are yours.
Okay, thank you so much, Tim. I really appreciate it and very happy to be joining you all today. As Tim mentioned, we'll be discussing the environmental containment of geomembranes and really doing a comparison between filled and fabricated different lining systems. So I'll just go ahead and begin. So this was a time study where we had a really unique opportunity to do a comparison of 2 different lining systems. This particular project was an opportunity where the specifier actually specified both a primary and secondary membrane. And so we were able to install these lining systems on the exact same footprint. And so what we wanted to do was use this as an opportunity to evaluate the installation requirements, both from a product perspective as well as a labor and time savings perspective of these 2 different materials. And so with that, this entire project was meant to be just a time study and really a more holistic evaluation of how different products would perform under these very similar and honestly identical settings. So with that, again, the lead engineer on this project specified both a primary and secondary membrane. And so what we were able to do was use 2 different systems. The first one was a field fabricated lining system, and the second one was a factory fabricated lining system. And what we were able to do was compare each of these products based on the performance characteristics, specifically for seepage containment. And the main variable, again, was the location of fabrication, either in a controlled factory setting or in the actual field. So I'll just hop in and discuss a little bit about the study design, and then we'll go forward and talk about the site and other aspects of this project as well. So again, the main purpose of this project and this study was to do an evaluation of the installation speed and the time required to complete an installation, again, on the footprint of this site. And we also wanted to evaluate the seam testing requirements and the time for completion of each of these different lining systems, as well as evaluate the seam quality and the total cost to the site owner. Now, one thing that I do want to mention is that, you know, as we go forward with product development and edits to existing products, we really wanted to take a more holistic approach to this product analysis and evaluation. And this is something that you can use in your own daily life, in your own daily work, as a way to really evaluate products for a more complete due diligence. So what we've done is we've used both quantitative and qualitative methods to understand not only the technical performance of the products themselves, but also the context for their use case. And we like to call this more of a holistic technical evaluation. As Tim mentioned, my role is products research or products researcher, and that's essentially how we combine these two areas for evaluation. And the reason why this is important is that it provides very actionable results because we leverage a variety of tools, not just what we're typically used to from a more quantitative perspective in terms of performance, but other ancillary items that can really give us more information around how the products will be used actually in the real world setting. Some of those tools that we like to employ are things like time studies, stakeholder interviews, as well as doing documented field installations, as well as prototype mock-up and reviews for any new products, and really having a full analysis of our decision criteria and the motivation that different stakeholders may have in selecting different products and their preferences. And the main result of this more holistic evaluation is that we have a very meaningful and differentiated innovation that we can take out into the marketplace. And when we're applying the combination, again, of both quantitative and qualitative data, there's a general methodology that we would suggest you employ. And essentially, you want to identify two or more materials or technologies that have very similar use cases. This, again, is going to allow you to have as close to an apples-to-apples comparison as possible. And of course, just as normal in any sort of evaluation, you're going to complete your normal technical analysis. But in addition to that, think about who the stakeholders are in the evaluation that you're doing and do what's known as a stakeholder map. On the right-hand side, you can see an example of this stakeholder mapping technique. And for an installation similar to the one that we've done here, for a normal geosynthetic install, your stakeholders want to be persons from the installation crew, the installation company, the site owner, as well as even the fabricator and other players like that. So doing a stakeholder map really allows you to understand what each party is needing out of not just the installation, but the long-term wear and durability of the product and the performance as well. This can also be done using stakeholder interviews and then identifying an appropriate test site to verify the use case. In our situation, we use a third-party owned coal-powered power plant for this installation because it was a site that needed essentially stormwater runoff containment. And at the end of employing this, again, you're going to be able to identify very tangible quantitative metrics to allow you to have that more apples-to-apples comparison. And again, there are many use cases in which this holistic evaluation may be helpful. Obviously, one of the first ones are new product development, as well as innovations to existing products, or any new markets that you may be entering into where you'd like to have additional understanding to really, again, bring that differentiated value. So I'll just jump right in and really talk about this particular job site in which this time study was evaluated. So what you'll see here is the technical drawings of the site location. This was, again, a coal-fired power plant that had a residual disposal landfill on its site. The landfill itself was going to be used for exhuming coal ash, and what you'll see outlined on the screen is a stormwater retention pond. This pond was about 7,500 square meters or over 78,000 square feet. So we have both metric and standard conversions here, but about 7,500 square meters for this surface water pond. And it was essentially designed to store the runoff from the ash that came from these landfill operations. What we have here is a video of the job site itself. This was located in the northeastern United States. And these are aerial shots of the entire facility. So in the background, you'll be able to see the actual power plant itself. And in the foreground, you can see the landfill as well as the footprint of this stormwater retention pond. Okay. So when we think about different products that could be used in this situation, we had some very clear evaluation criteria that we wanted to maintain. And this goes for both of the different products that we did install. So the first one was in the installation criterion, the total install cost. So really wanted to evaluate the labor and the skill level of the labor, as well as the time required for the install of each of these products. As we go forward, we'll have a full conversation about the different labor requirements for each of these different products, because obviously, as you know, labor is certainly a significant line item for any of these projects. In addition to that, as the site owner is going to employ additional third-party expenses for the installation, including quality QA testing. Now, we do know that the QC, or the quality control, is included in the installation price. I should mention that we hired a third-party installer, CQA Solutions, to complete the installation for this particular experiment. In addition to that, we wanted to really look at the durability of the materials. So things like their puncture resistance as well as their tensile strength. And that, of course, is going to relate to the installation quality because different products may have different wrinkles as the environment changes. Wherever there's overlap of the products, wrinkles can occur. And of course, those are going to be potential leak locations. So if we can minimize wrinkles as much as possible, so much the better. And items that are going to reduce wrinkles are things like how flat the product lays, as well as the quality of the seaming. And then finally, and one of the most important is the fitness for use. So obviously, we want to use a material that is specific for the material that is going to be maintained, as well as that the product lasts for the amount of time that has been specified. Okay. So in terms of the methodology for this work, this pond, again, was specified for both a primary and secondary lining system. So the primary lining system, so again, it had two different lining systems, excuse me. So the first one was a 1.5 millimeter or 60 mil fill fabricated lining system. And the second one was a 1 millimeter or 40 mil factory fabricated lining system. Now, in the middle, what the geosynthetic clay liner was specified. And again, we did both a qualitative and quantitative assessment that included the installation complexity, the labor requirements, as well as the stakeholder interviews. So in terms of the protocol, after the subgrade was prepared, the factory fabricated lining system was installed first, followed by the geosynthetic clay liner, and then the fill fabricated lining system was installed on top of that. And each of these products were obviously needed to have some field welds in place in order for that final installation. And so each of those welds were evaluated for their integrity as well. I just wanted to take a moment and really discuss what the factory fabricated lining system protocol is like, just in case anyone is not familiar. So what makes factory fabricated lining systems separate from field fabricated lining systems is that they are able to be pre-welded in larger panels prior to deployment out into the field. And why this is important is because this fabrication can occur in a very controlled, clean setting. So as you can see in the images on the screen is that the rolls, the different panels can be rolled out and seamed in a controlled setting. And so again, what this does is this allows the panels to be specially customized for the site that they're going to be installed onto, which is quite nice. I should mention that EPI did the fabrication for this situation here. Okay. Now, after these panels are prefabricated in the factory, they can be deployed in two different fashions. The first one is that the panels can be either folded, and the second one is they can be deployed in rolls. If they are folded, then those large panels, again, they are pre-welded, and they can be delivered to job sites in stacks, as you can see on the upper left-hand screen. Once they're deployed on site, the panels are then unfolded and deployed in place. On the upper right-hand side of the screen, I'll identify this here. The panels are unfolded and they're open and then pulled across the entire coverage area. And then, of course, field seaming is required wherever those panels require connection. And so that's what you can see here as the laborers that are pulling out these panels after they have been unfolded. And then wherever there's overlap, that's where this field seaming will occur in these factory fabricated systems. So they are prefabricated, but you do need to do field seaming wherever that overlap does occur. Very similarly, and they can also be folded and deployed into rolls as well. And so this is very helpful for larger projects where the folded systems just may not be as appropriate. So these rolls can be quite large. They span 20 to 25 feet wide, and they can be quite long as well, so 800 to 900 feet in length. And they are very heavy, so they can be upwards of 4,000 pounds or 2 tons. And so actual machinery is necessary to place them. Once they are placed, they are typically deployed, again, mechanically using additional equipment, and they are deployed one roll at a time. Again, once they are rolled out, then the panels are unfolded and deployed in place. It's very similar to the folded systems. So just going ahead and transition to the project at hand. So again, we are back at this coal-powered power plant, and you can see the subgrade has been prepared on the retention pond here in the foreground. I also want to mention that each of the, the factory fabricated panels were installed first, followed by the geosynthetic clay liner, and then the field fabricated system was the final step. What you're seeing here is the prepared subgrade with the sandbags already in position for the first prefabricated panel. I do also want to identify that there is one pipe penetration that's located here in the lower right hand of your screen. And CQA Solution completed this installation for this project. So what you're seeing here is the factory fabricated lining system. There's a shop drawing, essentially, the fabricator prepares for the installers to aid them in this deployment process. And so for this particular site, again, for the prefabricated panels, there were 4 panels that were deployed. And you can see how they're deployed here on the screen. So they were delivered to the site in rolls, and they were rolled out along the length of the pond, and then the installers pulled them out along the width of the pond for final placement, and then ballasted where these lines are here. So I'm about to show a video of this actual installation. And again, what you're going to see in the video is the rolls have already been deployed. They've been rolled out, and the first panel will be installed as shown here, followed by the second panel, the third one, and then finally the fourth. And so the way the video is oriented is the installation will go from the background towards the foreground. And again, the fabrication company in this particular project was EPI. So again, we have the subgrade here. This is a different visual, and we're about to see the installation come from the background towards the foreground. And I do want to mention that this has been accelerated to 3,000 times speed just for the sake of this presentation. And this video lasts about 10 seconds. So don't worry if you miss it first, I will play it 2 times just for your benefit. So you'll see here panel 3 being installed, and then panel 4 on this left-hand side. So I'll play that one more time because it did happen quite quickly. So in the background, we'll see panel 1 being installed and ballasted, panel 2, panel 3, and then the 4th panel. Okay, great. After the factory fabricated panels were installed, the field fabricated panels were installed on top of that, again, with the geosynthetic clay liner. So the GCL is what you will see in white here, and then the black plastic installed on top after that. And again, this video was sped up at the same 3000x speed, but this one took about 1 minute to complete with this accelerated time. Okay. Perfect. All right. All right. So now I'd like to transition and talk about some of the things that we found after doing these two installations. So again, they were installed on the same footprint as you just saw in those videos. And we began with having the factory fabricated liner installed directly over top of the subgrade. Then we had the geosynthetic clay liner installed on top of that, and the field fabricated liner on top as the last step. So, when you're looking at these two different lining systems, they are different. And regardless of what you actually install on the site, you are going to have to complete some field seams, and all of those seams are going to have to be tested after welding for their integrity. So on the factory fabricated liner, the field seams were completed with a single track wedge welder. And we did double check all of the factory fabricated seams with air lancing, as you can see in the image here on the bottom left. On the right-hand side, you'll see what was done on the field fabricated lining systems. These seams were completed with a dual track thermal fusion welder, and air channel as well as destructive testing was done on each of those, again, to just double check the integrity of those seams that were done in place. Okay. Now, one of the questions that comes up is about wrinkles and the ability of the system to wrinkle. I've included some additional photos from a different installation project just to show more of a side-by-side comparison of these two lining systems in the real world. So these photos actually come from a lithium mine in Argentina, and this was the test sites before the actual installation. So on the left-hand side, you can see the factory fabricated system, and on the right-hand side, you can see the field fabricated system. Now, I don't know about you, but I can see certainly a larger amount of wrinkles on the field fabricated side. And if I have a lithium mine, I'm really going to be concerned about if there are any tears in the system and how visible they will be. You really have to think about what it is that you're containing. If it's something that you want to maintain, then making sure that the integrity of that system is of utmost importance. And so what you'll see here is just a close-up of the field fabricated system. And these two systems were installed at the same time, and these photos were taken at the end of the day. And so what we noticed is that, field fabricated lining systems, they can display some expansion as the ambient temperature rises throughout the day. And of course, this can create some challenges when it comes to welding, as well as having intimate contact with the ground. And so obviously that can lead to some compromise of performance if you don't have good contact with the ground with whatever your lining system is. Now the factory fabricated liner, again, this was installed at the same time as the previous one in this lithium mine. And you can see that this one is quite smooth, and it's a very nice, smooth, dare I say, almost wrinkle-free surface. So I just want to take a little bit of time to transition to talking about the stakeholder perspectives. So we've just talked about the install itself and how the products performed and the welding techniques required for each of them. We also, again, wanted to take a more holistic evaluation for this project and really look at all the different stakeholders and what their opinions are and what mattered to them when it came to these different products, again, on this particular site. So a lot of the stakeholders that we had conversation with and had interviews with were persons such as the engineer specifier, the site owner, as well as the installation company owner, the day of manager, in addition to the crew themselves. So what we've done here is outlined, based on the responses that we received from the interviews, what the different stakeholders mentioned as part of their interviews as what stuck out to them, as well as we've denoted with a thumbs up what the stakeholder viewed as a benefit to them from their perspective. So from the engineer specifier's perspective, they noted the number of seams. So in this particular, in our landfill where we are exhuming the coal ash in this retention pond, we noticed that there were 3 seams that were required for the factory fabricated system because, again, we had most of the seams were prefabricated prior to install. However, for the field fabricated system, there were 191 field seams required. So from the engineer specifier perspective, this required less documentation on their side. For the site owner, they were really taking note on the number of wells that were required, again, out in the field. So on the factory fabricated system, it required fewer wells, which to them, they did see that as a benefit. Moving on to the installation company owner, a number of things that they pointed out. One was the puncture resistance and the tensile strength of the individual products, as well as the number of wrinkles, the amount of time it took to install, the number of panels and field seams, as well as the amount of essentially quality and destructive testing that was required. So from the installation company owner, having fewer wrinkles on the factory fabricated side was a benefit in their regard. And they did notice that for similar conditions, the field fabricated system did have more wrinkles on that particular site. They noted that there was less time for the installation to be completed. So the factory fabricated system took about a half day to complete the install versus the field fabricated system took more than 2 days to install, because again, it did require the GCL as well as each individual panel to be welded in the field. For the installation company owner, they did also note the number of panels that needs to be deployed out in the field. On the factory side, of course, there were 4 prefabricated panels versus on the field side, there were 95 panels that were installed. And in terms of the destructive testing, more time had to be spent on the field fabricated side to complete all of that destructive testing. For the installation day of manager, they were really concerned or noted the amount of QAs that were needed. So on the factory fabricated system, fewer QAs were required versus on the field fabricated system, they did have to do more QAs over more days. And they also needed to abrade the surface to complete their evaluations as well. Additional stakeholders that we interviewed included the installer, again, and then we also took note of the crew size, the welding differences, and some additional product differences as well. So from the installers, these people are out in the field installing these products day in and day out. And I should mention that this was the installer, the installation crew that installed for this particular project. This was their first time installing on the factory fabricated system. They were experts at the field fabricated system. So the fact that they noted a faster install on a factory fabricated system, even though it was their first time, is definitely something to note. They also wanted to mention that the wider panels covered more surface area versus the larger volume of panels needed on the field fabricated system. And again, the amount of destructive testing that was required. Now, we do want to note that when you have these larger panels and you're deploying them out into the field, you're going to need more people to just do the maneuvering of these larger panels. So we did notice that we needed 20 to 25 crew members to deploy these really large prefabricated panels versus, of course, in the field fabricated system, 10, 11, 12 guys can really get the job done. So on the factory fabricated system, you needed more labor, but they did need to be lower skilled. So you could pay them, they had a lower hourly rate than the specialists that were needed for the field fabricated system. Also, in terms of the welding that was required, again, on the factory fabricated system, this was done with a single track wedge weld versus on the field fabricated system, they did do a dual track. And so, again, I do want to note that this was our installer's first time installing this factory fabricated system. So even though they only took a half a day, there was some time that was required to really dial in the appropriate setting. So the temperature settings as well as the speed in order to get the welding completed on this factory fabricated system. Versus they were very much experts and accustomed to installing on the field fabricated system, so they were very fast in actually doing the welding on that particular product. And they also noted that the scrim could cause, because the factory fabricated system that we used did incorporate a scrim, that could cause the welding to be a little bit more difficult, again, as they're getting used to the new product. And they did have to do the grinding before the extrusion welds on the field fabricated system. And just to highlight a few more product differences, the amount of product deployed was the same for each of these products. The factory fabricated system was 40 millimeters thick, and the field fabricated system was 60 millimeters thick. I also want to note that, again, we double checked all of the prefabricated or factory fabricated system seams on the factory fabricated system. What a mouthful. So we did air lance those just to double check those factory seams were of good quality. And then on the field seams for the field fabricated system, those were air channel tested for that dual track. So when we took an account of the entire amount of time required for each of these two lining systems, the factory fabricated system took just under 6 hours to complete the install versus the field fabricated system took upwards of 16 hours. I do want to note, this is real world installation. And so we experienced it all. We got rain delays and everything else. And so the time associated with those adverse weather conditions were removed, and just the time to complete the actual installation is what is reported here. Okay, so what you can see here is the completed installation time. And again, for the prefabricated system, this installation time was about 6 hours. So, when you think about 6 hours, sometimes it's hard to really get an understanding, in real time, what does that mean? So I wanted to present this time lapse on the screen, as you'll see here. So this is the beginning time for from when the subgrade was prepared to when the prefabricated system was deployed. So from 8:30 a.m. to lunchtime, the entire ground is covered. Okay, and so that's just a significant time change when you think about the amount of labor that's required and the amount of time that your crew needs to be on site. So, one of the things that we're going to discuss a little bit later is just the full, complete due diligence, as you're specifying for different products, as to, you might need more men for the prefabricated system, but if you need them for less time, it definitely warrants another look. These panels, again, for the prefabricated system, they were welded together with the Demtech, again, single track wedge welder. The average temperature setting, again, we did have to do a little bit of working out the kinks to determine what the appropriate setting would be. So for this one, the temperature setting was between 700 and 750 F, and the speed setting was approximately 14 feet per minute. So just wanted to highlight a few more stakeholder perspectives. So these are direct quotes that came from our interviews. So this is exactly what the stakeholders thought after seeing both of these products installed on, again, the same footprint. So from the site owner, he's saying, hey, if this is in big sections, then it's going to be much better because have fewer wells with the factory fabricated geomembrane than you normally would with the 15 or 20 foot wide rolls, speaking of the field fabricated system. The installation company owner remarked that they felt the prefabricated system was a little bit more foolproof. There were less seams and less holes, less walking on the material, and so essentially they noted the ease of installation that made a difference to them in their role as the company owner for the install. Again, because these factory fabricated systems are prefabricated, or majority of the seams are done in a control setting prior to bringing on site, the installers noted that these larger panels, obviously they cover a lot more ground. And so with one factory fabricated panel, they were able to cover the equivalent amount of surface area that would take about 6 to 7 of the field fabricated system panels. From the engineer perspective, the engineer's job is really to make sure that they are able to specify the best quality product that also meets the site owner's budget and performance criteria. So from the engineer's perspective, they noted that if the material is cheaper, if it performs well and installs quicker, then there's no reason for them not to make the change or at least consider it as a part of their specifications. And then for the installation day of manager, they were really focused on the reduction of QA time, and they thought, that was quite serious in their perspective. For the factory fabricated geomembrane, they noted that would be a big reduction in third-party costs, particularly to the site owner. So just wanted to show a few more videos that really highlight the different attributes of these two systems. So just to dive in a little bit deeper, because I know the first videos can be a little bit further away. So in the field fabricated system, you can see here the individual panels as well as the seaming that was done for each of them. And then on the factory fabricated system, this is where the fourth panel is being deployed. And this is almost in real time. So you can see that the rolls was rolled out here on this side here, and the gentlemen are now pushing it to bring panels 3 and 4 together where they would have their field seam completed. So a high-level summary of everything that we've seen today. On the field fabricated system, we had smaller panels that had consistent panel widths. On these field fabricated systems, this liner system, there were 95 panels that were deployed and 191 field seams. And because none of them were done before deploying out to the field, all the seams were done out in the field, so all field seams. The total length of field seams that were completed is 5,387 linear feet. And in terms of the length of weld repairs, there were 2,145 linear feet of extrusion weld repairs completed on the field fabricated system. This equated to 253 weld repairs. Of course, these are smaller rolls. However, the installers were very familiar with this system. It has proven field performance and they required fewer but higher skilled laborers. On the factory fabricated system, again, we had these larger, more customizable panel sizes, and that's because the 4 panels that were deployed were prefabricated in a control setting prior to bringing out into the field. Because there were 4 panels, there were 3 field seams required, and again, this was a combination of factory fabricated seams as well as field seams out in the, where the panels overlapped. Now, I do want to mention, with these lining systems, you can do all field seams if you so choose, but the real attribute is the flexibility of being able to do the factory fabrication to save the amount of time and to cover more ground once the installation is on site. The total field seam length that needed to be done in the field for these factory fabricated systems was 418 linear feet, and the linear feet of weld repairs was 108 linear feet. So the number of extrusion weld repairs were 12. So there was less linear feet that needed to be seamed in the field, therefore fewer repairs, so forth and so on. Of the 2 different products, the factory fabricated system did have a higher puncture resistance, great tensile performance, and then in terms of labor, there were more laborers required, but they required a lower skill. And then when we think about the total time required, they required about 1/3 of the total time that was needed for the field fabricated system. So overall, there was less time that it took for this installation. And when you think about it, the less amount of time that is required for the installation, that means that there's less risk that your subgrade is going to need additional work on it because it's exposed to the elements for a shorter amount of time. So, as we go forward here, we really just want to implore to you, both of these systems are going to need, of course, part of your due diligence plan. And so the real idea here is not to really sway you one way or the other, but, encourage you to do a complete due diligence. I'd be remiss if I didn't mention that the fabricator, they add additional value to the system. And so that is additional cost that you're going to have to evaluate as a part of your specification when you're really determining what is most appropriate for the project that you have at hand. Okay, so this more holistic evaluation, it doesn't just look at the products themselves and just that original line item. It's really about what additional costs are going to be incurred, of course, by the site owner for the quality control mechanisms that need to be employed. The test methods are going to be required, as well as the labor costs included as well. So again, we're looking at our complete due diligence. It really is worthwhile to incorporate not just the products themselves, because that is important, but really what is that holistic cost? What is the additional value that the fabricator will add to the factory fabricated system, as well as what additional labor you may save by having more men, but less skilled laborers on the factory fabricated system versus on the field fabricated system. You can, if you're specifying a job, yes, you will need fewer men, fewer installers, but they're going to need to have more specialized skills going forward. So it's all a part of your, again, your real evaluation and complete due diligence. And so that is really what I wanted to leave you with today. So with that, I'll thank you so much for your attention, and certainly welcome any questions. Tim, you can take it from here. But this is a photo of the completed site, and certainly thank you for your attention today, and certainly to welcome any questions from here.
Great, Richelle, thanks so much. And we have a lot of questions, so here we go. Let you take a minute here. Oh,
thank you for a bit of water.
Yeah, first, for those people attending, we did get a couple of questions that they thought today's session was on leak location. That was the original plan. It had to be rescheduled for April 28th. So that is Tuesday, April 28th, 2020 at noon Central Time. So I apologize for those that we're looking for leak location, but it's just a week away, a week and a half away, and I hope you'll be able to attend. Okay, so Richelle, and I'll just kind of boil these down and put them somewhat paraphrase them. Was there additional material installed over the joints of the GCL before the upper geomembrane was installed? If so, what was it and why was it installed?
That is something that I will have to get back to you on. Again, we hired a third party to do the installation. So I am not familiar with exactly what different seaming mechanism they had to use on the GCL, but I can certainly get that for you.
Okay, great. Ian, I'll get that to you as soon as I get it. Okay, next is factory fabricated liner. Did that affect installation speed of the field fabricated liner? I'm not sure.
So I don't think it affected the speed. I think the fact that we needed to install the GCL was a larger influence on the install speed of the field fabricated system, specifically because as you install the GCL, you can only put so much GCL down before you have to come on top with that field system, because you can't have the GCL installed and just have it exposed to the elements. You don't want it to get wet or anything like that. So installing those in tandem had much more of a larger impact than having the prefabricated system in first, because remember, the GCL was installed on top of the prefabricated system. So essentially, once the prefabricated system was down, your subgrade's covered and you're quote unquote good from that perspective. So the only thing that would be a hindrance for the field fabricated system for how fast it could be installed, one, the installer, and how fast they could lay the GCL down.
Yeah, exactly. And maybe that's a good point. The factory fabricated geomembrane was installed first, protected the subgrade,
Yes,
which is a little harder to repair than just cutting out some pieces of GCL. So that
absolutely.
makes a lot of sense. Absolutely. Okay. For the lithium mine, why didn't the factory fabricated geomembrane wrinkle when exposed to the same sun temperature as the field fabricated? So I'll let you take a swing at that one first.
Well, we think it's due to essentially the thermal expansion of the two different products. So essentially, the different products are going to have different behaviors and different coefficients of thermal expansion, and so that's really what's going to determine how much it relaxes under those ambient conditions versus not.
Yep, absolutely. And so, Dan, there's a ASTM test to measure the coefficient of thermal expansion, so you can check that out of the materials you're considering up front, and then that gives you an idea of the wrinkle potential. You can also
Absolutely.
perform the dimensional stability test on the materials being considered, which is ASTM D1204. Okay, when do you do the leak test or the pressure test? And I think that what they're asking is the air channel test, in the field or in the factory.
Oh, so I should reiterate, and I think I put this on here. Let me just put that again here. So the prefabricated system in the field is done with a single track welder. Here we go here. So those field seams of the prefabricated system is done with a single track welder. And so essentially when you're double checking the factory seams, you just air lance those because those are done already. But you don't need to do air channels on those because it's a single track. On the field fabricated ones, because that's done with the dual track, those will be air channel tested in the field after install.
Okay. Let's see. If you don't do the test in the factory, well, you air lance it. I think you already covered that. The factory geomembrane is air lance tested in the factory and the field, and that's how you double check the factory fabricated.
Right.
Yeah.
Exactly.
Yep, I think we got it. Okay. Next one is, oh, I think that's the same question. Okay. How long did it take to prefabricate the products or the geomembrane in the factory?
That's a good question. As we mentioned, we hired, there was a third-party EPI that did the fabrication. I don't know how long it takes them to do. I mean, this is their business, but I'm sure I can reach out to them and find out and get that information to you. But I don't know how long it takes them to do their process.
Okay. Lance will get you that information. Next is, as the factory fabricated geomembrane, what is done during the transportation? In other words, can that factory fabricated geomembrane be damaged during transportation?
Oh, that's a good question. I imagine that it could be, because essentially, the individual panels are still made even on the factory fabricated system, right? Then they have to be warehoused, then sent to the fabricator, then sent back to the warehouse, and then sent out to the site, which is why I was mentioning that fabrication section. It does add additional value to the process and to the project, so there's additional cost there. So I imagine that it could be damaged in a certain sense, but they package it quite well. To be honest with you, I can show you some of I think I showed some of the rolls versus oh, my battery's running low. Sorry about that. So you'll see here that they do take precautions on placing some additional cushions underneath the straps when it is folded, and then when it's rolled, it is also strapped down as well. So is it possible for it to be damaged? I imagine so. I don't know if we have any like claims or anything like that about damages. I can find out more information about that. But I think that the fabricator does a quality job in trying to make sure that the product can withstand transportation and have as much quality as possible.
Yep.
Excuse me 1 minute. I'm just going to get my laptop charger.
For that listener, there is an ASTM standard guide. It is ASTM D as in David 7865. It's called Standard Guide for Identification, Packaging, Handling, Storage, and Deployment of Fabricated Geomembrane Panels. ASTM D7865, and that gives you good details on how to package and ship it. If you can't find that, please contact me. Let's see.
Sorry about that. Just wanted to plug in and not lose battery.
Okay. Next one is, how do total costs compare? Factory fabricated versus field fabricated. I guess pre-deployment costs for factory fabricated geomembranes would be higher. Actually, I'll let you that, but I think that's lower than field fabricated. Thanks. Very interesting presentation from Oscar. So can you talk about wages for factory versus field and costs?
Absolutely. So of course, as I mentioned, this is part of your due diligence. Obviously, depending on how complicated your project is and things like that, that's going to all weigh into what your costs are. But in terms of wages, on the factory fabricated system, again, wages for the lower skilled labor is about $10 to $12 per hour, but you do need more of them. So you're going to need about 20 to 25 guys to pull out these panels. As you can see, even on the screen here, you'll see we have a large row of gentlemen that are really, pulling this out. And so you might need more men and about double the amount of laborers, but the cost per man is less. And then, of course, you only need them for a shorter amount of time. So it's really a question of, how much does it cost me to have 20 guys for $10 an hour for 3 hours versus having $20 or $25 an hour specialist laborers and having them on site for 2, 3, 4 days. So, depending on how complicated your project is, things like that is going to certainly weigh into those total costs. So hopefully that answers your question.
Yep, and that dovetails to the next question. Are you able to calculate a cost savings ratio between the two different systems? In other words, say the factory fabricated geomembrane was 20%, 30, 40% less than the field.
I don't have a cost savings ratio, just because of this was an experiment. So we have some, some concessions on costing there. But I imagine that you could certainly price it out. Essentially, you just need to have the specifications of your site, your fabrication costs, your actual material costs, and then weigh out, if I have my prefabricated system, I imagine it's going to take me, I don't know, an hour per panel plus another 2 hours for the actual welding to occur, something like that. Versus you should be able to determine how long it would take for a normal install of a field fabricated system and then be able to do that costing ratio that way. But depending on how much transportation you need to go from your fabricator back to your site, all those things are going to weigh in. So I can't speak to exactly what it will be for your particular project, but you certainly should be able to calculate that ratio. But I can figure out what it was for this particular one if you're interested in that cost ratio for these two.
That would be great, Richelle, if you could do that, and Lance, we'll get that to you.
Certainly.
Looks like the last one. Was there any third-party QA/QC required to observe the factory fabricated seams? In addition, was destructive testing required on the factory fabricated seams?
Destructive testing was not required on the factory fabricated seams. CQA Solutions did both the install and the QA/QC. So there was no, so that third-party cost was combined in their install fee, if that's part of your question.
Yep. And Sean, there is an ASTM standard practice, ASTM D as in David 7982, standard practice for testing of factory thermofusion seams for fabricated geomembrane panels. And what this ASTM test method does is it requires destructive testing on trial seams, not the production seams, trial seams at the start of the day and periodically throughout the day and at the end of the day to make sure the factory seaming is meeting specifications. Okay, great. Richelle, if you could run to the end of the presentation.
Certainly.
And we'll wrap up.
And I have in my notes to get in touch with the fabricator to determine how long it took for their fabrication, as well as the cost savings ratio. So I'll circle back with you on that, Tim.
Great. Thank you, Richelle.
Certainly.
And for all of the attendees, if you have additional questions, please feel free to email them to me. We always have a follow-up podcast, and we have it scheduled next week with Richelle. And Any remaining questions I will present to Richelle in this podcast, and we will post it later next week.
Certainly.
Before we end, our next webinar is Understanding Leak Location Surveys for Owners and Inspectors. Sorry, we had to back this up a week and a half. It is on Tuesday, April 28th at 2020 at noon Central Time. Matt Chemnitz of Leak Location Services will give this presentation. It's an extension of the presentation in Charleston where he only covered a little bit of understanding leak location. So those of you that were looking for leak location, it is next Tuesday. I'm sorry, April 28th, so it's 2 Tuesdays.
2 Tuesdays.
Yeah, away. And then let's see, is there any other slides, Richelle? Yeah, so I'd like to encourage everybody to visit the FGI website. We have a couple minutes. I'm going to demonstrate the resources tab of the website very quickly. This is where you can look at the other webinars that we've recorded and listen to the other podcasts as well. Okay, so here comes, hopefully this is going to show my.
Do I need to transfer
Yes.
the screen to you? Let's see here.
Yes.
How can I do that? Oh, I think you have control. Perfect.
Okay, so under the resources tab right here on the front page, you can see new podcasts, our webinar library and PDH library. Let me focus on that today because we're finishing up a webinar. So here are the upcoming webinars. Leak location on April 28th. We have a post-closure care of landfills webinar coming up on May 19th. And on June 16th, we have testing and design of geosynthetic drainage composites. And then on July 16th, we have package handling and storage of geosynthetics and fabricated geomembranes. So let's see, who was that? Lance or Oscar? If you wanted to learn more about how to package and handle it, it would be July 16th. And then we have August 20th, geomembrane wrinkles. Now, below this are all the prior recorded webinars. And with our PDH system, you can watch any of these webinars at any time. My screen will refresh right there. And you download the slides, watch the webinar, and the blue button to the right will, now just turn yellow orange because I touched it. You get your PDH certificate after watching the webinar. So I hope you'll take advantage of our PDH credit system and watch as many webinars as you would like. So I want to wrap up today and thank Richelle again for an excellent webinar and joining us from Columbus, Ohio. Richelle, thanks for joining us, and we look forward to recording our podcast with you next week.
Thank you so much, Tim. This is fantastic. Really appreciate the opportunity.
Thank you, everyone, and I hope to see you on April 28th for leak location at noon Central Time. Thanks for attending.